Bismillah ar-Rahman ar-Rahim. Assalamu alaikum. In this lesson, we are going to discuss about the electromagnetic spectrum. Electromagnetic spectrum. First of all, I'm just going to recall what are electromagnetic waves and few of their general properties. Electromagnetic waves are those waves which can pass through vacuum. These are those special kind of waves which do not necessarily require a material to pass through. That means even if there is a material, they will still not be blocked. They would still be able to pass through if there is a material available. But even if there is not, they would be able to pass through them. They have a fixed value of speed. They have a fixed speed in air or vacuum. We should memorize that value. See the speed of electromagnetic waves in vacuum, that is 3 into 10 raised to power 8 meters per second. We should memorize this. Thirdly, all the electromagnetic waves, EM waves, they are all transverse in nature, are all transverse in nature. This is an important fact that we should be able to recall when needed about the electromagnetic wave. That means they can pass through vacuum, they have a fixed speed of light, that they have a fixed speed in vacuum, and they're all transverse wave. These three are important facts that we should memorize for them. Spectrum. The word spectrum indicates a collection of similar things. So electromagnetic spectrum means the 7 kinds of electromagnetic waves that we have, we arrange them in a certain order. We need to memorize those values, those names in the specific order that I'm going to tell you. First wave is a radio wave. The second is a microwave. The third kind of electromagnetic wave is infrared. The fourth is the visible light, then ultraviolet, then the X-rays, and the last is gamma rays. The name for this is gamma. We need to memorize all these values in the exact same order. You can start memorizing from gamma, then X-ray, then ultraviolet, then visible light, then infrared, then microwaves, then radio waves, or you can memorize the other way around as well. We should remember that all these waves, they are electromagnetic. That means they are identical to each other. They have same speed in vacuum, except that they may have different wavelengths and they may have different frequencies. Okay, if I say they may, that means only X-rays and gamma rays, these are the rays which have their wavelengths overlapping each other. Otherwise, they are all going to have different wavelengths. We would have to memorize the values, the approximate values for the wavelengths. I'll tell those to you in a minute. Radio waves, they have largest wavelength, whereas gamma rays, they have smallest wavelength. We should remember that frequency is inversely proportional to wavelength. So if a wave has a larger or increasing wavelength, it needs to have a smaller frequency. So of all these 7 electromagnetic waves, radio waves are going to have the smallest frequency. And gamma rays, which have the smallest wavelength, they are going to have the largest frequency. In our syllabus, we need to memorize their approximate values of wavelength. It's a requirement. So a radio wave usually has a wavelength that lies in the range 10 meters to 100 meters. That's the approximate value for the wavelength of radio waves. Microwaves, their wavelengths are approximately 10 raised to power minus 2 meters. That means if you multiply a number with it, that is probably going to be an electromagnetic wave. So we need to memorize 10 raised to power minus 2 as an approximate value for microwaves. Then infrared. Infrared have an approximate value from 10 raised to power minus 5 to 10 raised to power minus 3 meters. That's the approximate value for infrared. For visible light, all of them have a value from 10 raised to power minus 7 meters. Ultraviolet, they have a value of 10 raised to power minus 8 meters of wavelength. Gamma rays, they have an approximate value of 10 raised to power minus 10 meters of wavelength. And gamma rays, they have 10 raised to power minus 12 meters of wavelength. These are all approximate values. If you would like to Google them, everywhere you might find slight variation in their approximate values. So you don't have to worry about that. You can memorize these values from whichever book or notes that you want. They will be approximately equal to the ones that I have quoted here for you. But you need to memorize these values. Examiner will ask you to estimate the approximate wavelength of, let's say, ultraviolet. So if you remember the wavelength value, then you'll be able to estimate it. Okay, so these are the approximate values of wavelength. The visible light, it has 7 different colors in it. We have already studied those in O level. Red color, orange color, yellow, green, blue, indigo, and violet. We need to memorize these wavelengths in the specific order. Wib Geor or Roy G. Biv. Red color has the largest wavelength, that is approximately 700 nanometers. Then there is orange, that's going to be 650 nanometers of wavelength. Then there is yellow, that's 600. Green has an approximate value of wavelength, let's say 550. Blue has 500. Indigo is 450. And violet is 400. These are all approximate values of wavelength of the 7 visible light colors, and you will have to recall these values. So you should memorize them. Take a little break and see if everything is clear so far. All right, so here is a question. Examiner will ask you to estimate the frequency of blue light. This is an exact past paper question. Examiner wants you to estimate the frequency of blue light. It's an MCQ question. You can expect such a question in paper 2 as well. You would have to recall frequency is equals to V over lambda. This comes from the general wave equation V equals to F lambda. We want to estimate the frequency, so the wavelength goes on to the other side and gets divided. Just recall that blue light is an electromagnetic wave, so it needs to have a speed of 3 into 10 raised to power 8. Now you divide it by wavelength. There is no wavelength given in the question, but here you would have to recall an approximate value for the wavelength of the blue color. If you look at this, the approximate wavelength of blue was given as 5 into 10 raised to power minus 7. All you have to do now is just solve this by using your calculator, and you're going to get 0.6 into 10 raised to power 15, or you can write it as 6.0 into 10 raised to power 14 hertz. That's going to be the approximate frequency of the blue light. Examiner does not need to know that you have calculated. So this part here has to be hidden from the examiner. Because in estimate, examiner is not expecting you to perform calculations. So you can perform this on the rough page, rough work. Examiner doesn't need to know this. This is the answer that examiner needs to know. So this is what you're going to write in your paper too, without actually showing the working for it. Okay, let's take a break and see if you understood that. Here is another example for you from the same concept. That is, examiner says, how many wavelengths of red light are in 1 meter length? That's an interesting question. Examiner says, if there is a length that is 1 meter, how many wavelengths of red light are going to be there? Okay, examiner is asking you to find out how many wavelengths. That's one wavelength, that's two wavelength, and examiner wants you to find out how many wavelengths will be there in 1 meter. Okay, for that you should recall that one wavelength of red light, that was 700 nanometers. Just for you, just for your sake of discussion, I am going to write this 700 in terms of nano. That's going to become 10 raised to power minus 9 meters. And when I include these two zeros with the 10 raised to power minus 9, this becomes 7 into 10 raised to power minus 7 meters. This is exactly what I did over here. This 7 into 10 power minus 7 can be written as 700 nanometer. It has just become a custom to write down the wavelength of light in nanometers. There is no real logic behind it. Okay, so instead of 700 nanometers, I can write 7 into 10 raised to power minus 7. 7 into 10 raised to power minus 7 meters. How do I know that's one wavelength of red light? Of course, we would have to memorize the wavelength of red light, that is 7 into 10 raised to power minus 7. Now, examiner wants you to find out how many wavelengths. So underneath the wavelength, I'm going to write down X, are present in a length of 1 meter. So this 7 into 10 power minus 7 was in meters. Underneath that, I'm going to write 1 meter. I'm simply using the ratio method here. I'm going to cross multiply them. This becomes 1 lambda into meters equals to 7 into 10 raised to power minus 7 meters multiplied with x. Meters and meters cancelled out. 1 lambda divided with 7 into 10 raised to power minus 7 gives you x. Now simply just calculate that by using a calculator. I suggest you always use the brackets. So find out what is going to be the answer for this. 10 raised to power 7 divided by 7. What do we get? Okay, I'll just calculate that by a calculator. Okay, I don't have a calculator. I'm sorry. Do you have a calculator? Can you solve it for me? Right. So this tells us that X, that was what? X was the number of wavelengths, comes out to be 1428571 wavelengths. That means 1 meter of a length is going to have 1.43 into 10 raised to power. I'm just expressing this in standard form. 1, 2, 3, 4, 5, 6, 10 raised to power 6 wavelengths. That means that the wavelength of red color is so small that inside a length of 1 meter, that's how many wavelengths of red light are going to be present.